Good day, everyone. My name is Loreto Atamosa. This is the second part of our video discussion on Module 3, Lesson 7. On the first part of our video discussion, we discussed about some of the most important concepts in the production and cost. We are now on the second part, and let's start with the law of diminishing returns. So the law of diminishing returns holds that we will get less and less extra output when we add additional doses of an input while holding other inputs fixed. In other words, the marginal product of each unit of input will decline as the amount of that input increases, holding all other inputs constant. So from our example, the law tells us that it would be absurd for a company to have workers beyond the point of negative returns or even to approach that point. However, we would certainly want to keep hiring workers who yielded increasing returns. And if your company found it profitable to increase output still further, it would keep hiring workers even though their returns were diminishing. And when we say increasing marginal returns happen when the marginal product of an additional worker exceeds the marginal product of the previous worker. So we can also say that there is increasing marginal returns when a small number of workers are employed and arise from increased specialization and division of labor in the production process. While decreasing marginal returns, on the other hand, all production processes eventually reach a point of decreasing marginal returns. So decreasing marginal returns occur when the marginal product of an additional worker is less than the marginal product of the previous worker hired to do the same task. So decreasing marginal returns arise from the fact that more and more workers use the same equipment and workplace. Thus, as more and more workers are employed, there is less and less production for the additional worker to do. So diminishing return and marginal products refer to the response of output to an increase of single input when all other inputs are held constant. But sometimes, we are interested in the effect of increasing all inputs. Now, there are three cases should be distinguished. Constant returns to scale, which indicate a case where a change in all inputs leads to a proportional change in output. And second, increasing returns to scale, also called economies of scale. It happens when an increase in all inputs leads to a more than proportional increase in the level of output. And the last one, we have decreasing returns to scale. It occurs when a balanced increase in all inputs leads to a less than proportional increase in total output. And let's proceed with the theory of cost. So in business term, cost is half the picture. So the other half is sales or total revenue. So cost refers to all expenses acquired during the economic activity or the production of goods and services. So it includes expenditures incurred for the utilization of various factors of production in the creation of goods. Therefore, sales minus cost is equal to profit, or total revenue minus total cost is equal to profit. Now, we have a video presentation which is prepared to us by Khan Academy to better understand the idea of total fixed cost, total variable cost, and total cost. Here, let's watch this.
We here at the Khan Academy are working on some type of a software project, and we need to think about what's the optimal number of programmers we should hire. At least think about how much productivity we're getting per programmer when we are working on this software project. And so what I've done over here, this is a spreadsheet, so I'm not going to be able to write. I'll only be able to type. This is Microsoft Excel right over here. In this column, I have the different numbers of programmers. And then let's say based on other studies or industry studies or past experience, this tells us how many lines of programming code we can get per month. And obviously lines of code isn't maybe the best way to measure things because someone can write good lines or bad lines of code. But let's just say this is one way of measuring productivity for software engineers. So the first thing I'm going to think about is what are my fixed costs? So what am I going to spend no matter how many software engineers I hire for this project? And for the sake of this video, my fixed costs will be the office space and the electricity, and let's assume assume I just have an office that can accommodate any number of these programmers. So that's a fixed cost. That's not going to change depending on the number of programmers that I have. And then the other fixed cost, let's say I have a product manager for this project, and I'm going to pay her salary to essentially help spec out what this software should actually do. So her salary is, let's say, $10,000 a month, and then another $5,000 a month in office space for everybody. So it's going to come out to $15,000 a month. And that's not going to change regardless of however many programmers I have. So I'm going to go into Excel. I'm going to go to this little bottom right over here, and I'm going to drag that down. And so it's going to be $15,000 in fixed costs, no matter how many programmers I end up hiring. Now the variable costs. Let's assume that the full, sometimes people, well, let's just say that the full compensation for a programmer is $10,000 a month. So if you include the cost of their salary, if you include the cost of their health insurance, you include the extra goodies that they will eat from the company kitchen, whatever it might be. So it's going to be $10,000 a month. So my total variable costs are going to be $10,000 times the number of programmers. So here I'm going to write equals, and I'm going to write it's going to be $10,000 per programmer times that little snowflake. I pressed Shift 8 to get that snowflake, times, and I could say times whatever is in that cell. So you see it's cell D7. And actually, let me scroll this over so that you can see, so you can actually see the cells. So that is cell D7, and let me press enter. So that's so it's $10,000 times D7, which is this one right over here. And I just selected that, and I can press enter. And right now, that's nothing. Let me scroll over so we can see everything a little bit better. Let me scroll over a little bit to the, there you go. I'm having trouble. Okay, there you go. Now, what are going to be my total costs? My total costs are my fixed costs plus my variable costs. So that's going to be equal to, and I'm just using my arrow keys right now. It's going to be equal to F7, right? That's cell F7 plus this one, plus my variable costs. My total costs are my fixed costs plus my variable costs. And so it's $15,000. And actually, I can make this true for every row over here. And this is one of the really useful things about a spreadsheet, is I defined this cell as being $10,000 times whatever this cell, or times whatever this cell is right over here. And so what I can just do is I can just drag that all the way down. And for every one of these, it's going to take $10,000 times the cell that's essentially 3 to its left. So now this is going to be 10,000 times D8. This will be 10,000 times D9. And let's look at that. So we can see right there, 10,000 times D9. And you could, if you click on there, you can actually see what the formula is, 10,000 times D9. So by dragging that, I was able to get the right formula all the way down. Now the total cost for every row here is going to be 2 to the left plus 1 to the left. And so if I drag that down, it'll do that for every row over here. So now this is 25 is the 15 plus the 10. 105 is 15 plus 90,000. Our total costs are fixed costs plus variable costs. Now let's think about the average fixed costs. And the average fixed cost, we're going to think about it in fixed costs per line of code produced. And over here, line of code produced is 0. So you're going to divide by 0, which is undefined. So we could leave that blank, but we could fill this one in. So our total fixed cost, this is going to be our total fixed costs, which is cell F8. I just use the arrow keys to select F8, divided by our total lines of code per month. So divided by our total lines of code per month. And so that gets me $3.75 fixed costs per line of code. And then I can do the same thing that I've been doing before. I can drag this down, and then we see what the fixed cost is. So at any given point, if I take the fixed cost, $15,000 divided by the lines of code, I get $1.38. And this actually makes sense, because the more programmers I add on to this project, the more lines of code I get, I'm using the same fixed costs. I'm using the same project manager. I'm using the same office space. So the cost of that project manager, that office space, gets spread out along more and more code. So the fixed cost per line of code goes down as we add more and more programmers. Now, what is the average variable cost? So once again, the variable cost is going to be whatever the variable cost is per lines of code per month. So when we're talking about average, we're talking about average cost per line of code. And maybe I should, so this is per line of code, let me write it over here, per line of code. And I can even say per month. Per line of code per month. Actually, I wanted that to spread out more, but the way I've set it up, so let me scroll down. Whoops. I'm having issues here. All right. Well, these are all per lines, average lines of code per month. And so let's think about what happens with our variable costs. So I'm also going to start here because I don't want to divide by 0. So in this month, our total variable costs were $10,000, and our total lines of code are going to be $4,000. G8 divided by E8. And so average variable cost per line of code is $2.50. And then what happens? So let's do that for every row over here. So when we do it for every row, something interesting happens. Our average fixed cost went down because we're taking the same cost and we're spreading it out amongst more code. But our average variable costs went up. As we added more programmers, per line of code, it actually cost us a little bit more on average per line of code. And that's actually, if you look here, as we add the incremental lines of code we get per programmer is actually going down. That first programmer by themselves, she can write 4,000 lines of code. But then that second programmer is only, you're not getting to 8,000, you're getting to 3,000. And probably because they have to coordinate with each other, they have to plan a little bit more. It's not all in one person's head. Then when you add the third one, you're not even adding 3,000 lines of code. You're only adding 2,000 lines of code. And this is actually a real phenomenon that actually happens in companies. The more people you add on to a project, obviously they can maybe do more work, but there's also more coordination. There's going to be more meetings. There's going to be more interruptions. And so each person's individual productivity is going to go down. And this isn't to say that this third coder is somehow worse than the first coder. On average, all of them are now only going to produce 3,000 lines of code a month, when maybe individually they could have each produced 4,000 lines of code, but they have to spend some of their energies now coordinating it. And so that's why our average variable cost per line of code is going up. As we add more and more people, it's getting us incrementally, it's becoming more and more expensive on average to write that line of code. And if we look at average total costs, that's going to be, and this is once again, this is per line of code, it's going to be our total costs, H8 divided by the total lines of code per month. So if we just hire one engineer, we're going to have $6.25 spent per line of code. And that's because a lot is spent on, and this is actually just the sum of these two right over here. And then let me make that true. Let me set that formula for every row. And so we see something interesting. When we start to hire a few engineers, we're able to spread out our fixed costs. Even though our average variable costs per line of code are going up, our fixed costs are going down. So we're getting a little bit of a benefit because we're spreading our fixed costs per line of code. But then it starts to get expensive again because, as we said, the more people you have working on the project, they're going to have to spend more time coordinating with each other and maybe even undoing each other's work or redoing each other's work as opposed to just writing the actual software. And now let's think about the marginal cost. The marginal cost, the best way to think about it is, what is the incremental cost of that next set of line of code? So one way to think about it, so this is going to be how much more you're spending divided by how much more code you're getting. So how much more, so for example, how much more, and this is going to be once again per line of code. So once again, so we're spending, when we go from 0 programmers to 1 programmer, we're going from $15,000 of total cost to $25,000 of total cost. So we're going from, we do in parentheses, 25, if we're going from 15 to 25, that means we're increasing our expenditure by 25 minus 15. And so that's why I'm doing H8 minus H7. So that's how much more we're spending in expenditures. And then how much more code are we getting? Well, we're getting 4,000 minus 0 lines of code. And the reason why I'm doing the formula this way is so that when we drag it down on all the rows, the formula will be right, because it's relatively taking the right cells into account. And the reason why I'm saying it's average is because this is saying what's the incremental cost per line of code for this first 4,000 lines of code. And then we can go from there and we can drag it down. And now this tells us the incremental cost per code for the next 3,000 lines of code. And once again, it got a little bit more expensive because we're getting a little bit less efficient as we add more and more people. And there's something very interesting that happens here, and you might have even noticed it in these numbers over here. We actually get a negative marginal cost. And this isn't meaning that when we add more lines of code, somehow we're getting money. It's actually saying that as we spend more money, we're actually killing lines of code. Because at some point, if you have too many people on this one project team, they actually start killing each other's productivity. And you can even see it right here in the numbers. When we had 7 people, we were able to write 11,400 lines of code. But then the 8th person, because of coordination, it's not that this 8th person is incompetent. It just, when you have 8 people in a team, everyone's productivity goes down so that you're only able to produce 11,200 lines of code. And that's why you had this negative marginal cost. Now when you get to 8 people, all of a sudden, by spending more dollars, you're actually destroying some of what you are actually trying to produce. So what I wanted to do here is just to really get you behind the numbers and really maybe give you a little sense of how you can actually do this with a spreadsheet and get you thinking a little bit about how a firm's cost structure might actually work.
Great, isn't it? Therefore, total fixed costs are the sum of all consistent non-variable expenses a company must pay, while total variable cost is the aggregate amount of all variable costs associated with the cost of goods sold in reporting period. So it is a key component in the analysis of corporate profitability. While the total cost is the actual cost incurred in the production of a given level of output. In other words, the total expenses or the cost incurred, both explicit and implicit, on the resources to obtain a certain level of output is called the total cost. And another video presentation is prepared to us by Jacob Clifford to better understand the idea of average cost, average fixed cost, average variable cost, and average total cost, including its part 2 video for the graph illustration for this kind of cost. Here, let's watch this.
Hey, how you doing, Econ students? This is Mr. Clifford. Welcome to ACDC Econ. In the previous video, I defined the different types of costs: fixed cost, variable cost, total cost, and marginal cost. You used the chart to calculate each one of these, and you also calculated the average cost curves: average variable cost, average fixed cost, and average total cost. If you haven't seen that video, make sure to go back because you're going to need that for what we're going to do right now. Because right now, we're going to find out what these cost curves look like on the graph. If you plotted the total cost, you'd come up with a graph just like this. Right here, the horizontal line is fixed cost, and then right here is variable cost. Now, since fixed cost plus variable cost equals total cost, the total cost curve would look like that. You might see this graph on a test, but really it's not as important as the per unit cost curves. I'm talking about marginal cost, average total cost, average variable cost, and average fixed cost. The per unit cost curves look like this based on the calculations we did in the previous video. First is the average fixed cost. Notice how it keeps getting smaller and smaller and smaller. It's an asymptote. That's because you're taking the fixed cost, which is a set amount, and dividing it by larger and larger quantities. So the average fixed cost is going to keep getting smaller and smaller and smaller. Next up is the marginal cost curve. Marginal cost always goes down and up because the law of diminishing marginal returns. Average variable cost goes down and up, and it hits marginal cost at average variable cost minimum point. The average total cost also goes down and back up, and it hits marginal cost at ATC's minimum. Notice the vertical distance right here is the same as the vertical distance right there. That's because the average fixed cost plus the average variable cost equals the average total cost. Now let's talk about how you're going to actually use this graph. You might get a question on a test that says, how much does the 5th unit cost? To figure that out, just go straight up from 5 units. The graph tells you the marginal cost of producing 5 units is $20. The average total cost of 5 units is 14. The average variable is 12, and the average fixed is 2. Again, remember, the average fixed of 2 plus the average variable of 12 equals the average total of 14. But the best part of this graph is the fact that you can use it to calculate total costs. For example, you know that each one of those 5 units costs $14 on average. Well, how much does 5 units cost in total? What's the total cost of 5 units? Well, it's $70. It's that box right there. That's the total cost. Of that $70, how much is variable and how much is fixed? To figure that out, all you gotta do is go up to the average variable cost at 5 units, which is $12. 12 times 5 is 60. So that box right there of $60 is the variable cost of producing 5 units. If the variable cost is 60 and the total cost is 70, then the fixed cost must be 10. That's the average fixed cost of $2 times 5 units gives me $10 of fixed costs. That's the box right there. Yeah, all right, I kind of like this. I'm getting into cost curves. I kind of like it. Yeah! Cost curves! Woo! Cost curves, cost curves, cost curves! You're going to be using these cost curves a whole lot, so feel very comfortable calculating the total, variable, and fixed costs. What you're going to find out is that not all four of these curves are equally important. The real important ones are marginal cost and average total cost. Those are the ones you're going to be drawing a whole lot. I hope this video helped you understand cost curves. Make sure to check out the next video. It's going to talk about the shape of those cost curves, and check out my review app for the AP exam, alright? Till next time. Hey, how you doing, Econ students? This is Mr. Clifford. Welcome to ACDC Econ. Right now I'm going to talk about cost curves. If there's one complaint about learning microeconomics, it's cost curves. I mean, no one gets excited about cost curves. They might not be exciting, but cost curves are super essential. Now, someday you might own a business, and it's important to understand the cost of production. Calculating your costs is going to help you figure out your profit, but it also helps you figure out how many units to produce. And you're going to be doing these calculations for costs and drawing the cost curves a whole lot in microeconomics. So although it seems kind of bland, it's time to get excited about costs. So let's go over the different types of costs. Every company has two different types of costs: fixed costs and variable costs. Fixed costs are the costs that don't change with the amount produced. Like if you're a pizza company, the oven, right? You only have one, it's a fixed resource. It doesn't matter how many pizzas produced, you still have to pay for the oven. Another example might be the manager's salary, right? You still need a manager whether you produce 1 unit or 1,000 units, and so the manager's salary is a fixed cost. So variable costs do change with the amount produced. So if you produce more output, you're going to need more resources. So raw materials, labor, electricity are all examples of variable resources, and that's variable costs. If there's only two types of costs, fixed and variable, then total cost must be fixed plus variable cost. And there's also marginal cost. Marginal cost is the additional cost of producing one more output. If you're a pizza restaurant, it's the cost of producing one additional pizza. It's the change in total cost divided by the change in output. So now you understand the total cost. There's total fixed cost, total variable cost, total cost, and marginal cost. Now let's see if you can calculate them on your own. Right here I have the cost for a given firm. Right, we have 0 output, we got 1, 2, 3, 4, 5, 6 units that they could produce. I've also given you the variable cost and the fixed cost producing no output. I want you to copy this chart on your piece of paper and finish off these columns. Calculate the fixed cost, the total cost, and the marginal cost. Pause the video and then do those calculations and I'll go over the answers. What's the fixed cost of producing 1 unit? Well, it's $10. For 2 units, it's $10. For 3 units, it's $10. Why? Because it's fixed. It doesn't matter how many units produced. You still pay $10 fixed cost. Total cost is the variable plus the fixed cost. So when you produce nothing, you still have a total cost of $10. Remember, that's because you have to pay that fixed cost. For 1 unit, it's $20. For 2 units, it's $27. Then 35, 50, 70, and 120. And it's really that simple. Variable cost plus fixed cost equals total cost. The marginal cost is the change in total cost from producing an additional output. So if the total cost of producing nothing is $10 and the total cost of producing 1 unit is $20, the additional cost of that first unit must be 10. Since the total cost of 2 units is 27, the additional cost of that second unit must be an additional $7. So again, the marginal cost is the change in total cost divided by the change in output. So it's $8, $15, $20, and $50. Now that you can calculate these costs, let's calculate the per unit costs. There's average variable cost, average fixed cost, and average total cost. The average variable cost is the total variable cost divided by the quantity. Average fixed cost is the fixed cost divided by the quantity. And the average total cost is the total cost divided by the quantity. Most of the time when you see these, you're going to see them by the acronym. So ABC, AFC, and ATC. Get used to that. Now let's go see if you can actually use those equations and calculate the average cost curves. I want you to calculate the average total cost of 6 units, the average fixed cost of 2 units, the average variable cost of 4 units, the average total cost of 1 unit, and calculate all three, the average variable, average fixed, and average total for 5 units. So go back to your paper, number 1 through 7, and make sure to calculate each one of these. Pause the video and I'll go over them. Alright, the average total cost of 6 units is $20. That's because the total cost is $120 and we're producing 6 units. So if the total cost is $120 and you produce 6 units, how much did each one cost on average? Well, $20. The average fixed cost of 2 units is $5, right? It's the $10 fixed cost divided by 2 units. That gives us $5. The average variable cost of 4 units is the $40 variable cost, total variable cost, divided by the 4 units that we produced. So it's going to be $10. The average total cost of 1 unit is $20. If 1 unit costs a total of $20, then on average, that 1 unit costs $20. Now let's take a step back and find out something you might not have noticed first time around. Notice that the average variable cost plus the average fixed cost equals the average total cost. For example, for 5 units, the average variable cost was $12, the average fixed cost was $2, and the average total cost was $14. 12 plus 2 equals 14. That's how it is for every single one of these. The average variable cost plus the average fixed cost equals the average total cost. Actually, this is not that bad. I kind of like cost curves. The next thing you're going to do is going to take all these costs from the chart and you're going to put it on a graph. To learn more about that graph and to find out how to use it, you got to watch the next video. If you like these videos, make sure to subscribe and leave a comment below. Okay? Till next time.
That is amazing, right? Therefore, the average fixed cost is the total fixed cost divided by the quantity of output produced. So you will note that as output increases, the average fixed cost falls continuously, while the average variable cost rises with output. Average variable cost is the total variable cost divided by the quantity of output produced. So usually, it declines for a while as output increases, but eventually, it levels off when then begins to rise as more outputs are produced. While average total cost is the total cost divided by the quantity of output produced. It is also the sum of the average fixed cost and average variable cost. So average total cost is sometimes referred to as per unit cost. So let's proceed with marginal cost. Marginal cost, or MC, is the cost of producing one additional unit of output. So marginal analysis asks how much it costs to produce an additional unit of output. Therefore, marginal cost is the change in total cost when one additional unit of output is produced. So stated in other way, marginal cost is the ratio of the change in total cost to a 1 unit change in output. And lastly, the decision to operate or shut down. So a firm has 2 options in the short run. It can either operate or shut down. So if it operates, it will produce the output that will provide the highest possible profit for the firm. If it is losing money, it will operate at that output at which losses are minimized. So if the firm shuts down, its output is 0. Shutting down, however, does not imply 0 total cost. So the firm must still meet its fixed cost. Now, why can the firm not go out of the business in that short run? Because it still has fixed cost. Now, these obligations must be discharged. Therefore, any plant, equipment, inventory, raw materials must be sold off. Now, all of this takes time. How long? Now, it will depend upon the type of business. Now, another question is, when does a firm operate in the short run? So, a firm will operate in the short run when total revenue exceeds variable cost. And how about when will the firm shut down? Now, a firm will shut down when variable cost exceeds total revenue. And that's it for our lesson 7. Thank you for listening and stay safe and healthy. Goodbye!